Okay, good evening everybody. Hopefully you can all see my screen, and I'm trying to get this into presentation mode, so that looks like it. Okay, well, good evening everybody. My name's Will. I'm new to the club, and I'm going to be just talking about a filter that I made probably going back a year or so now that really helped me clean up my noise in the shack, and really sort of something I've stuck with ever since, and it's something that's pretty simple to make. The guy that I really took this from is a guy called Ian White, GM3SEK, and he did a presentation to RSGB and really showed quite significant improvements and changes to his receiver performance and also his transmit performance. So I've been an avid shortwave listener for many years. So before I actually got my license this year, I decided to give this a go. It was simple enough that I could build. And Ian did a very good job in his presentation of explaining some of the technical issues and the choice of the Ferrites and other bits and pieces that really made sense to me. And I thought, well, this is something I can have a go at. So I've put down there 3 links. One is to Ian's presentation, which if you've got the time to take a look at, I'd urge you to do so. It's really quite informative. It certainly was for me anyway. The other one is a link to his blog, which talks about this filter in a bit more depth, and people have added some extra stuff into there and asked him some questions, and the blog is still live. I think the last entry was on the 3rd of this month, so it's pretty current still. And one of the other links is another YouTuber who built a filter that Ian talked about, and also implemented some chokes that Ian showed in his presentation at the RSGB, and was talking about the improvements that he'd seen in his shack. So it was quite compelling. So where does this noise come from? So I'm probably preaching to the choir in a lot of cases here, but a lot of what I'm going to talk of tonight is noise and interference that comes up through the mains, and in particular the earth lead. So anything that really plugs into your mains and chops the supply, like switch mode power supplies, phone chargers, laptop power supplies, battery chargers that may be sitting in the garage, are sources of noise. In addition to that, digital data on mains or phone lines can cause a lot of interference too. And Ian goes on to talk about that it's very probable that the main supply is heavily polluted with RF interference, and it's something that we can't really rely on trust to give a decent earth to help reduce RFI. And in a lot of cases, it actually makes things worse. And this was certainly the case in my QTH. So what are we trying to do? So Ian shows a slide where he has shown a dipole with a balun coming down to a coax, through a coax, sorry, onto a choke before it gets into the station. So this is really trying to take any noise that's coming in off the antenna and being passed down the outside of the coax out of the shack, and keeping the common mode currents out of the shack. Not only does it come into the shack, but it passes through those equipment and it goes into the main supply. Ian then shows us, through the use of the mains choke, how he stops with that choke mains borne interference coming into the shack, passing through the equipment and coming out the other side. So in essence, you're creating this island, if you like, where you're choking off any interference at either end of the shack, both on the main supply and also on the coax and antenna side. So what is this filter? So it really comprises of 3 main filtering elements. There's a 16 amp single phase mains line filter. The one that I used is the Schaffner filter, which is just a single stage filter. But the other one that Ian originally used was a Roxburgh design, and these have got quick fixings on it, so they're sort of crimp terminals that you can quite easily connect up. There's then 2 cores that he uses, ferrite cores. There's a large 31 type material, and I'll put the part number in there, and then followed by 2 type 43 oval ferrites that are glued together to make the figure of 8 and binocular core, and I've put the part number there too. The other components that are in the box are, well, a box, some cable glands, a mains cable, insulated crimps, and a mains power strip that actually connects to the clean side of the filter. In addition, I put in 3 metal oxide varistors just to take out any spikes that may be on the mains. I'm not entirely sure I've got them in the right place, but I'm sure people that are smarter and wiser than me can correct me if I've done anything wrong there. And the total cost of this was about £45 to £50, so it's a fair price. The parts that are listed here, there's certainly the ferrite cores you can get from Mauser, and a lot of the other bits and pieces, the box, for example, is from CPC. The Schaffner filter, I think that was from Farnell. So on Ian's website and the blog, which is one of the links on the second slide, you'll see a bill of materials in there. So again, depending on how many of these you want to make, or whether you already have some of the parts, obviously the price may vary. So the first thing that really sits in this filter is the line filter. So this is the metal-bodied can that is a single stage XY mains filter. Marked up line and load. Line goes to the plug, load goes to the further downstream onto the filtered side and the mains strip, power strip. One thing to note, I don't know whether you can see my arrow there, but there is a metal lug that connects to the can of this filter, which is where the earth lead gets connected. Depending on the type of filter you use, this earth lug can often be positioned in different locations depending on the manufacturer. So if you go to maybe a Roxburgh filter, you might actually find that this metal lug is on the other side. So one thing to be mindful of is, if you are going to maybe either play about with different filters here or design it to be able to take 2, is that you don't cut the mains lead on the inside, on the input, the earth lead too short, because you often want it to get across to the other side of the metal can to be able to cope with both product types. So that's the first filter element that sits inside the box. It then goes on to a second filter element, which is a ferrite core, followed by another ferrite core. Now Ian shows this chart, which is taken from Steve Hunt, who published it in 2015 in Radcom. This is actually a very informative chart, and it shows a lot of stuff on here. So these horizontal bars that are in colour show the impedance characteristics for different number of turns on different number of coils with different material type. So the N number here, 31, 43, 52, is the actual material type. The FT240 is the core and the size of the core. And you can see some of them have 2 cores, 1 core, 4 cores, and a varying number of turns. I've highlighted in this red box the ones that, the core material that I used in this filter, and you can see with these coloured bars how they perform. The darker green shows the impedance. So the darker the colour green, the higher the impedance is offered by the core. The red shows it being least effective on this scale, and the black bar that you see sitting in each of these horizontal channels shows where the resistive element is higher than the reactive element. so where it's really working at its optimum. So you can see that these materials are optimized for different frequency ranges. The other thing that is quite interesting to note is with the frequency going across the bottom, you can maybe make out these grey bars, which are actually the ham bands, so 160, 80, 40, 30, 20, so on and so on and so on. So you can, through picking a material, really tune this to maybe a particular problem on a band you're having, or make something that's maybe more general for several bands. The other thing that Steve has done here is actually add in some comparison for us. So this band that goes across the top of these bottom three is 10 ferrite beads of a 31 type material placed around an RG213 cable. So that's something that is often seen and sold on many sites. So you can see how that performs in relation to some of these other windings that are made on these other core materials. The second one down is 11 turns on an iron dust core. So these cores are often found all over eBay and are often a lot cheaper than the actual other ferrite toroids, which really should be used for this filter. And the bottom bar here shows effectively an ugly balance. This is 10 turns of RG213 cooled onto a 7-inch former. So you can see where that really offers its best performance, sort of around the 30 meter area, and less so either side. So this is a chart that I referred to quite a bit, and I've actually taken quite a lot from it, and it may be something that others find useful too. So after the first filtering block, which was that mains filter, the metal bodied filter, it goes into this type 31 ferrite winding. So this is a large ferrite core. And when I say large, it's not as the picture would show it on the Mauser website, which leads you to believe it looks more like one of these clip-on small ferrites. This thing is significant in size, and you'll see a picture of it, of Ian holding this core. It requires 7 turns. 6 need to be wound around the outside of the body and be equidistant as far as possible from each other. And the 7th turn goes straight through the middle and passes on to the next filtering stage. And you can just see maybe at the top there, these 2 other oval ferrites that are used to form the final 3rd filtering component. One thing to note is that you really do need to cut a fair amount of flex to do this. You need to strip it, and you need to wind these wires around so that they are in a spiral format like this. So I held them just under a book and used a screwdriver, just twisting the end to get them to actually form like this. I think Ian shows them actually, he holds one end in a vise and he uses a handheld battery power tool just to kind of wind them. But either way, they need to be wound pretty equally, and they need to be spaced like this and wound tight against the body of the core material. And then the last filter element is the type 43 oval ferrite, which requires you to glue 2 together to form this figure of 8, this binocular core. And there's 3 turns that go through this. And you really want this to be as close as possible to the previous filter stage. So it ends up looking something like this. So on the right hand side of this picture is where it would connect to the mains metal can filter. The left hand side then goes to a connector block, which is where you would connect in your 13 amp 3-pin mains plug sockets. And Ian's shown on here some of the frequencies that the cores have been wound to, and the effect, and where it has the most effect, sorry. you will recall from that previous chart, some of the windings had maybe 17 turns on them. So I think through experimentation and through Ian's knowledge, he's refined this to give it the best performance, really between 1.8 meg and 50 meg. So you can see this large Type 31 clip-on core on the left and how big it actually is. So if you do decide to go and order some parts, don't be fooled by the picture that you're going to see on Mauser. It is wrong, very wrong. And you can see here me building this up. I've just laid it literally into the box that was from CPC, and I'm just kind of getting a feel for how this is going to work. You'll see the earth lead at the bottom here onto the metal can, and this goes off to the plug, wall plug. And then I'm going to go through a process of winding these cores as per Ian's instructions, and then coming out to the left-hand side of this connector block. Now this is where my design differs a little bit from Ian's, is as much as I've got some varistas in here. So this top connector is live, middle one is earth, bottom one is neutral, and I've then got varistas across each live and earth, neutral and earth, and then on this side between live and neutral. And then through this grommet on the bottom right hand corner would go out to the power strip. That's what it looked like. So I actually have this seated as this is depicted here on the large flat bottom face. So I've literally held these three main filter components and the connector block in place just with Velcro, to be honest with you, just some really sort of industrial type Velcro. But if you were to stand it on its short face here, then you'd need to think of a different way of holding these, as obviously gravity is going to have an effect, and they're probably not going to stay in that format for too long. But this is the earth lug that I was talking about that comes in this case, on this Schaffner filter to this bottom right-hand post. And then you can see it looping round and then going into the filter here. In some filters, if you were to change this, either for a two-stage filter or maybe a Roxburgh, then this metal lug appears in some designs on the top. So you've then got to get this earth lead that comes in from the mains plug round to the top. So don't be too keen cutting this short if you want to put in a different filter. So the interesting thing here is that these metal line filters that are used are pretty much used on all sort of commercial white-bodied goods and other things like that. But they do a great job of really filtering the live and the neutral. But what comes in on the earth, you can see here, gets connected to the can and then goes straight out again. And this earth is often the one that Ian talks of as creating the biggest problem. Because in effect, it's bypassing this metal can filter, or this metal can filter has very little effect on what's coming in on this earth wire. So that's where this design is really quite beneficial, because then all three wires wound together go through these two filter elements and then off to the power strip, which comes out at the bottom right. So does it work? Well, it did for me. And it's easier maybe for me to see it than maybe it is for me to hear it, although I could hear it. I've only had this radio, this 8600, for maybe a couple of years now. Before, I never had the ability to see a screen like that, and I was very fortunate that I was able to get this radio. But you can see me tuned in here to the medium wave broadcast band. This is something that I was interested in at the time. I guess I still am. And with the nights drawing in as they were at the time, and the delay of disappearing at night, a lot more broadcast stations from further away could be heard. So what you see here are two identical setups, RF gain the same, filtering the same, frequency the same, mode AM both the same, and you can see the difference between the two charts. And literally you can see the time there in the top right hand corner. This 5 minutes was literally me just unplugging and plugging back in on the filter board. So you can literally see some signals there that very weak, but I couldn't see before, and you can definitely see the shape of these AM broadcast stations that were masked by this higher noise floor. So this is a chart that Ian shows on how this filter arrangement with the metal bodied blind filter and the type 31 and type 43 cores are really performing. This chart is across the bottom here, is in 5 meg divisions from 0 to 50 meg. And it's showing 2 traces. The one trace I believe is 21 meg and the other one is at 14 point something. And this is an impedance plot across that spectrum where he's showing here where this filter's really been optimized, which is right down here in the lower section of the band. Now, there is some discussion on his blog about actually choosing different ferrite materials to shift this response. So if anybody's interested in LF or VLF type work, then there is an opportunity to either change one of those core materials to a type 75, and you can get a type 75 clip-on core, which looks very similar in size to the type 31, or you could actually add it in, so you can extend that high impedance element right down into the lower frequencies and provide you with some good noise reduction. So that's it built. The top one in the top right hand corner is a picture taken from Ian's site. The one on the bottom there is mine, and it goes off to a mains power bar off to the bottom right. So that's just showing the cable glands tightened up and the crimps in place and how it's held. But I learned a few things on the way which are pretty important. One of them I learned the hard way, which was the first one, which is all of the shack's mains fed equipment needs to go in to the mains power strip. That's the clean side of the filter. What I did, I had a laptop connected to another household plug, and I had the laptop then connected via a USB cable to the receiver to try and decode some FT8. And all that did was take a dirty earth straight out of the wall and put it onto the clean side of the filter, and just completely negated the use of the filter. So you just got to be careful that you make sure everything in the shack that's mains powered comes from that main strip bar. And you can get these with sort of 10 sockets on. So depending on how big your shack is or what it is that you're trying to sort of guard against, there's some different options there. I've only got a small setup here. I've only got one receiver and one transceiver. So I can literally get away with about 4 sockets, and that's including the laptop and the monitor and a monitor, external monitor. So it works very well for me. The other thing that I found out, again the hard way, was I actually had a main strip that had got 2 USB sockets on it. I thought that would be a good idea because I could use both of them, one to charge my phone and one to power something else in the shack. But they often have noisy regulators that take the mains voltage and chop it up and then get it down to a 5 volt 1 amp characteristic, so you can feed everything else. They are noisy. They are really noisy, or at least the one that I had was noisy. So I found actually keeping this mains power bar as simple as possible and not introducing anything that again chops the mains on the clean side to be really beneficial and almost essential. Otherwise, you negate the filtering components in the box. This is only meant for obviously an indoor use, so I wouldn't want to put it anywhere else. It's not IP rated, although the box has an IP rating. Obviously the socket and plug certainly isn't. so indoor use only. And of course, the last thing is really try and find the cause of the electrical interference and remove it. And I did that by just walking around the house with a transistor radio tuned off station with the aerial up, pointing it at certain things. And I found out the worst offending item was my daughter's metal-bodied touch lamp, this on-off touch lamp that was creating a hell of a noise. And it was retired and replaced. But other people have tried and used different methods. Other people have isolated circuits on their main switchboard to switch off maybe downstairs sockets or upstairs lights or kitchen lights or whatever it might be, in an attempt to try and find maybe where the offending item is. So even though I've managed to clean up my feed into my station and removed some of my the noisy stuff that's plugged in elsewhere in the house mains, I've left this installed and I found it to be of great benefit. And it certainly does take the noise floor down and enables you to really hear some of the weaker stations. So that was really my implementation of Ian's filter with a slight modification. So I'd like to thank Ian for his video and his talk, because it kind of inspired me to kind of go away and build this, and the results I've had with it have been pretty good for me, very good. So I've been very pleased. So that's all I had to show everybody. So if you've got any questions, then I shall do my best to answer them. Thank you.
Just got one, Ivan, just got one question there for you, Will. I have a problem in having the feed to my house being brought up to date in inverted commas, where the protective earth and the neutral are actually bonded right next to the distribution unit.
Yes, I'm in exactly the same position. So that's the PME kind of bonding solution. So this is the first time we've had a PME kind of wired property. This one we're in now is 7 years old, 7, 8 years old, something like that. And I've not found any issues at all. And I don't think it breaks any of the or infringes any of the wiring codes or practices, but it certainly has made a difference for me.
Do you use an RF earth as well? Or,
yes.
And what was that, just a spike in the ground?
Yes. But it's not connected back to the PME feed into the property on the main side. Yeah.
That's fine as long as you use the side of 12-volt transformers on everything. If you've got a mains powered shack, your RF earth would then connect through the case of that mains powered radio.
Yeah, so I actually power, so everything in the shack is powered from a linear power supply. So it's only the linear that plugs into the the main strip board. And then everything else is running off a
I would just say if someone had a big home base that was plugged into the mains, as in it had its own power supply, you could have a problem with PME then, because you'd be connecting via the case of the radio to the RF earth to the mains earth.
Yes. Yeah, and if they lose an earth in the street as well, then you could have more than just your property that earth through that.
Yeah.
Lead as well.
Yeah, exactly. You suddenly find the case of your radio has become the primary earth for your street.
Where it falls flat in its face.
Yeah. and your earth wire burns up.
I had that happen on a UPS once. The file server, when I was using it in the shack, went via the UPS through to the RF ground, which was not nice.
Mm.
Yeah.
One of the best investments I ever had back in the day, when you could get, I don't know whether you can still get them from their online thing, it was from Maplin's, was this bad boy. You can either have it like that or open it out. Built-in surge protector, and it's 2.5 full 13 amp rating. Yeah, it's got a built-in surge protector.
Nice.
There's actually a part number on the back. If you can see that.
Yeah.
But when I do special event stations, particularly if I'm on generated mains, I always use that.
Oh,
And I've
definitely.
got a 10-way disc board which I can plug in as well, which is great unless, of course, you've got a load of wall warts. This one's wall wart friendly, but the other one isn't because it's a fixed block like that.
Mm.
And of course, wall warts are yet another bane of the life. Anything with a switching circuit. I find the new generation GU10 dichroic lights a pain. I've got a ceiling rose in here with 3 of them, and one of them, if I switch it on, the one which sort of points over where the dartboard is particularly noisy, so I always make sure that one's off if I'm operating in here, although generally it's just VHF, UHF in here. And computer power supplies are a nightmare as well, especially for laptops. One of the worst points of a laptop is the inverter inside for powering the backlight system.
Yeah, I certainly, as you saw from that plot, had quite a reduction in ground noise there. It was quite impressive actually to see. I didn't think it was going to have so much of an effect, so it was something that I was kind of quite taken back with. It was good. It certainly improved things for me, so it's nice that I can share it with you anyway.
It's great, yeah. Could you do me a favour, Will? Email me the links so I could put them in the YouTube description.
Yes, no problem. Yeah, I can do that.
We have to just click on the links then.
Yeah,
And
definitely.
you haven't put it. I got ready to take note, but you haven't put it on tonight. Can you email the your call sign as well?
Oh yeah, okay, yeah, no problem. I can do that as well. Yeah, no problem, Brian.
His call sign's at the beginning on the slide.
Was it?
2E0WCJ.
All right.
But I'll send it to you anyway with the links and with the because one of the links, like I said, has got a bill of materials attached to it, so you can just click on it. It actually goes straight to the site and to the parts that you saves you searching like through the Farnell and CPC sites and Mauser sites. It just takes you straight to the part. So I actually have got a Schaffner filter. If anybody is interested in having a go at building one of these, I can pass this on to them because this is a spare one. So let me know if anybody is interested.
Certainly think that the side-by-side before and after comparison on your spectrum scope there speaks absolute full encyclopedia worth of proof.
Yeah, definitely.
Yeah, well, I was a bit skeptical when, I guess that's just me. I've learned a lot more since I've obviously got my license, but being a shortwave listener, I was kind of a bit skeptical as to how and what sort of improvement I might see. I live in a house on a housing estate where there's 100 houses. It's kind of a new estate, and it's not kind of in the middle of the town. So I thought maybe it's going to be reasonably quiet. Maybe I'm not going to see much of a difference. But when I saw that, I was quite shocked, and that's actually below its optimum performing sort of characteristics. So it's really, Ian talks about this being tuned for 1.5 or 1.8, sorry, this 160 meters up to really 6 meters, with the better performance in the lower part of the HF band. So I was below that and still got a very good result. So I was really pleased with that. I've not tried the Type 75 material, which would take it down even lower, and the Type 75 material's not on that chart either, the chart by Steve. So but it is talked about on Ian's blog, and one of those links takes you to his blog, so you can kind of follow that if you are interested.
Yeah, but yeah, I said definitely that waveform, as Dave said, just spoke when you can see it visually.
Yeah, it's quite impressive.
Yeah,
and when I got it that low, when I then tried, for example, that was really after maybe a couple of iterations, because the first one I did had a mains power strip in it that had got 2 USB sockets on it, and that didn't drop it by much at all, because obviously they were just got something inside the mains power strip that was creating a lot more noise and putting it back onto the clean earth side. So once I'd kind of made that mistake and learned and just got rid of it and just put a simpler main strip on it, actually brought it down a lot more.
I suppose even if it doesn't matter, because they're not going to be connected to your shack in any way, it doesn't matter if you put your wall works on the dirty side of
That's right.
charge your and stuff.
Yeah.
It's only stuff that connects.
Yeah.
Alright.
The first mistake I made was actually powering the laptop off the mains, not from the filter, and then connecting a USB lead from, which kind of, I know for you guys is probably pretty obvious, but for me at the time, I couldn't work that out. And then as soon as I kind of, I could see it. And as soon as I then powered it off the clean side of the filter, everything was fine.
On the subject of USB connectors, that was how the earth bus on the UPS got fried. Was when I connected the computer to the radio, because the computer has only got 2 pins providing the power. It found its earth via the USB screen, and as soon as I plugged the USB lead in, and that made the earth loop via the UPS, and popped the Starpoint earth inside the UPS. Bear in mind, this was an earth track that was probably about 8 mil wide. It was quite surprising how that made like a large earth fuse.
Yeah, wow.
That's the last thing you want fusing is the earth. No, thank you very much, Will. That was really actually quite eye-opening.
Very good.
No problem. No problem. And good luck to anybody who's going to build it. I think it'd be, like I say, it was 50 quid, but it was 50 quid well spent. You could spend that and more on all of these noise cancelling boxes and bits and pieces, and maybe get similar results. I don't know, but it certainly worked for me in my location.
Just as a matter of interest, what was the leakage between the live and the earth in the primary filter? What current leakage was it?
I don't know is the honest answer. I'd need to take a look at the data sheet to see what the values there. On that primary side, they have got a resistor which I think is 320k between live and neutral. I think the choke is a 4 millihenry, and on the primary line side, it's got I think it's a 1 microfarad, 0.1 microfarad, and then 470 peak for the XY caps.
Oh, right. because I built something very similar to that some time ago, and all I was doing was tripping the circuit every time.
Oh,
Due to
okay.
the capacitor, the leakage between the neutral and the earth, but they were the same anyway, but between the live and the earth, and that was tripping it.
I think you need to be, from what I've read, I think some of these mains filters, some of them that are designed for the medical industry, have a very different setup in terms of the capacitance for the XY caps, and I think that, if you're not careful, could maybe cause what you've just described there, where you start to trip the breaker in the house. I can send on the data sheet if you're interested. You'll probably be able to make a bit more sense of it than I, but there's some more information in there that might help you.
The other thing to be mindful of as well is check what specification type of filters of RCDs you have on your consumer unit. Certainly remember from when I was occupying bench space at the former employers, one of the things we had, the big Regavolt that we had got a huge 5 kVA toroidal transformer in it, and we used to superimpose mains over the top of the secondary on that, which was two and a half turns of 270 mil copper to give the huge current and that. And because it's got such a high inductive load and low input impedance, you've almost got infinite input impedance, we had to use a different sort of RCD on the incoming mains distribution panel.